morning. Okay. So today we are going to study something about laws of motion. Right? In this laws of motion, first we will understand what is the content. Content is Newton's first law, then force, mass, Newton's second law, Newton's third law, and examples. Very important part is students are getting many difficulties to solve numericals. Fine. So, what is dynamics and what is statics? Generally, mechanics is a branch of science which deals with statics and dynamics of every body. Right? Now, question arises, sir, why we are discussing about mechanics? Because the motion is related with mechanics and related with body. Try to understand the concept very clearly. If there is no friction, we cannot walk. If the surface is frictionless, can we walk on that? Obviously not. So if there is no friction, we cannot walk on it. Fine. So what is mentioned over here? Please read.
Describe the relationship between the motion of the object in our everyday world and the force acting on them. Language of dynamics. Force, the measure of interaction between two objects. Pull or push. It is a vector quantity. It has a magnitude and a direction. Mass, the measure of how difficult it is to change object's velocity.
Fine.
Yes.
So it is clearly mentioned that the relationship between the motion of object in our everyday world and the forces acting on them. Whatever motion we are talking about is nothing but dynamics. If we are talking about objects which are at rest, then that is statics. That is statics. So language of dynamics means what all terms we will use under it. One, force. Second is mass. The force is the measure of interaction between two objects. That might be pull or push. There are n number of examples to understand force, and you are matured enough to understand it. It is a vector quantity. It has magnitude and direction. We have already studied what is scalar and what is vector. Scalar quantity is one which has only magnitude, no direction. This quantity which has only magnitude, no direction is called as scalar quantity, and the quantity which requires both is called as vector quantity. So what is mass? The measure of how difficult it is to change object's velocity. So the mass is one which consists of constituent material, and that mass or that body will be in motion or in rest once we apply a force or unbalanced force. Fine. So these are two, force and mass. These are the two terms which we are going to use in it. Right? So now further we need to understand something about measure of interaction between two objects. One is pull or push. One is pull or push. So n number of objects are shown over here. Can you see these objects?
Yes.
Right? Few objects are shown. Contact forces, field forces. Contact forces and field forces. What is meant by contact force and what is meant by field force? Yes. What is meant by contact force and what is meant by field force?
In contact force, we are applying the force on the object.
Where we are actually connected with the object. And the second one, field forces, they might not be connected with each other, but whatever field is created over there, that will affect the next, that is called as field force. Fine.
Yes, sir.
So vector quantity has magnitude and direction, may be contact force or field force. Contact forces result from physical contact, and field forces act between disconnected objects, also called action at a distance. Now forces, there are n number of forces: gravitational, Archimedes, friction, tension, spring, and normal. Fine. So these are few examples which we have seen over here.
Archimedes force.
We will see all these forces, but try to understand what are the types of forces. If we are talking about gravitational force, so Earth represents gravitational force.
Yes, sir.
Again, friction force, this car is representing friction force. Tension force, the person who is falling connected with the rope is representing tension force. Spring force, this here is the spring force. Normal force, this is normal force, and the Archimedes force is this one, right?
Yes.
Vector nature of force. Vector force has magnitude and direction. So wherever there is a word comes vector, you must keep in mind it belongs to magnitude and direction. Net force, a resultant force acting on object. Resultant force acting on object is called as net force. It means sum of all the forces acting on a body. Fine.
Yes.
You must use the rules of vector addition to obtain the net force on the object. Let us take example F1, F2, F3 and so on. All the forces are acting. These are all vertical forces, right? If you will tilt it or if you will pull it somewhere else, it will have vertical, horizontal, two directions of force, and the resultant is at the center where we have connected the rope. So F is nothing but F1 square plus F2 square, the whole root, and that will be 2.24 Newton. Why 2.24 Newton? Because they might have given values for that. Otherwise we cannot comment that it is 2.24 Newton. Fine. And the angle, if we need to find the angle between two forces, then what we should write? Theta tan inverse of F1 by F2. Now Newton's first law. What Newton's first law says?
Equal action as a
Action reaction is third law. First law. What first law says? Read this. An object at rest tends to stay at rest. An object is in motion tends to stay in motion. So it means if the object which is at rest remains at rest, object which is in motion remains in motion until and unless any unbalanced force acted on it. Fine.
yes.
What does it mean? It is inertia. It is about
Inertia.
Clear?
Yes.
So note this. So simply you can keep this in mind. When object is at rest, remains in rest. Object is in motion, remains in motion. And this can be termed as law of inertia. Law of inertia. Looking at this vehicle and the driver, both are moving at a constant speed. Let us take 60 km per hour. Now that person who is in
Motion.
car is also in motion,
Yes.
and car is also in motion. So both are in motion. Once the car hits to the wall, that wall tends to stop the car. But if seatbelt is not there, then person cannot be stopped. It will be in same in motion, right?
Yes.
So जब भी accident होता है तो we should take care of wearing seat belts. Otherwise, this will happen with us. Right? Newton's first law: when forces are balanced, forces are balanced, acceleration of the object is zero. Acceleration क्या रहेगा?
Zero.
Zero. How?
Back.
If the force is completely balanced, there will not be any acceleration, or if there is any acceleration and the object are both are in same direction, same speed, then they are relatively in rest. Two buses are moving at same speed. Two persons are sitting on different buses. Buses are moving at same speed in same direction. Then the two persons are at relatively in rest. But here it is not about relative rest. The net force is defined as the vector sum of all the external forces exerted on object. If the net force is zero, the forces are balanced. When forces are balances, the object can be stationary or move with constant velocity. That's what I said, no?
Yes.
अगर वो constant velocity से जा रहा है तो उसे भी हम लोग क्या कहेंगे? Relatively rest. Okay. Mass and inertia. Now what is mass? The matter containing by the body is nothing but the mass. Its unit is kg and it is scalar. Weight is vector, but mass is scalar. Sir, then what is difference between mass and weight? The quantity, the material consists of this object is nothing but its mass. So let us take, we are talking about this marker. So this marker has a mass of 20 gram for an example. So the mass will remain unchanged everywhere. Mass will remain same. But to measure its mass, we should what we should do? We should keep it on weighing machine. According to that machine will give you the value of weight. It means the object is giving force towards gravity, right?
Yes.
Otherwise we cannot measure the mass. So when there is a direction, that mass became weight. So that is vector quantity. Clear?
Yes.
जिसमें direction required है, that will be vector quantity. So what is mentioned? Mass is a measure of amount of inertia. Mass is a measure of resistance of object to changes in its velocity. Two balls are kept over here. One is larger and one is very smaller. So in this, if we will compare this two, right? If we will compare this two, we can easily understand this is very heavy and cannot be easily moved. So that is creating inertia on its body. Depending upon mass, inertia will increase. If mass is more, inertia will be more. Okay. Second law, acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Try to understand what it says. Directly proportional to the net force acting on it. On it means on object, and inversely proportional to its mass. So here what we have written, we have one fixed and we are stretching it somewhere.
Yes, sir.
So we are applying a force trying to give acceleration.
Yes.
So acceleration is nothing but summation of all the forces. Summation of
All
the forces. And that summation of all the forces is called as net force. So if I arrange this net force, then the formula became this mass will go this side.
Yes.
So that is F net is equal to M into A. M is mass, A is acceleration. Actually what we have derived acceleration. Acceleration is summation of all forces divided by mass. Right? Why mass? Because in first law we understood until and unless we will not understand the mass and its inertia, we cannot accelerate it.
Yes.
Right?
Yes.
अगर मुझे पता चला कि मुझे एक साइकिल को धक्का मारना है, so I can understand how much force I need. But if I think about a truck and if I am alone is there, I cannot move that truck. So I will think
Yes, sir.
that I need to increase
Force.
force and then that force will be divided by mass and accordingly I will get acceleration.
Yes.
Clear? So SI unit of force is Newton, mass is kg and second square, meter per kg, meter per seconds square. So in some other countries they are calculating it as pound. 1 Newton is 0.225 pound. So this LB is nothing but pound. Weight also measured in LBS is a force, mass into acceleration. What is the acceleration in that case? So acceleration will be force upon mass. More about second law. You might aware of this, right? In this, you must be certain about which body we are applying it to. Means, अभी just मैंने दो example दिया, एक cycle और एक truck. So we must be aware कि किसको force देना है. F net must be the vector sum of all the forces that act on the body. Only force that act on the body are to be included in the vector sum. So net force component along an axis gives rise to the acceleration along that same. So net force is nothing but mass into acceleration on x-axis, and net force is nothing but mass into acceleration on y-axis. Why we are talking about this? Because we have two components over here, x and y. In this picture, we can easily understand all are rushing behind that ball.
Yes, sir.
If all are applying the same force from all the direction, no one can move.
Yes.
So somewhere you should release the force and then you can get that ball free. Right?
Yes.
If all are applying the same force from all the directions, no one can move that ball.
Yes.
Right?
Yes.
So somewhere we should release the force and then we can get that ball in our hand. Okay. So it's time to solve numericals. One of two forces act on a pug that move over frictionless ice along an x-axis. So इसका जो भी मूवमेंट हो रहा है वो कैसा है? frictionless. कैसा movement है? Frictionless. In one-dimensional motion, the Earth's mass is m is equal to 0.20 kg and forces F1, F2 are directed along the x-axis and have magnitudes F1 that is 4 Newton, F2 2 Newton. Force F3 is directed at angle theta that is 30 degree and has magnitude F3. Fine. So F3 is 1 Newton. In each situation, what is the acceleration of the puck? So we know that F net with respect to x is max and F net with respect to y is may. So here we should have only x, y because they are talking only about horizontal direction. We are not talking about vertical. So F1 is equal to ma, a is equal to f by m. So 4 Newton was given. Here 4 Newton was given, right?
Yes, sir.
So that is divided with 0.2 kg and the answer is 20 meter per second. The second force we can write F1 minus F2 is ma, right?
Yes.
Because algebraic sum of all. So ax is nothing but F1 minus F2 upon m. So F1 is 4, F2 is 2. So 4 minus 2 upon 0.2. Then third part, F3 with respect to x. We are talking about this. सर इसमें माइनस क्यों किया अगर ये क्वेश्चन है? फर्स्ट का तो क्लियर है.
Yes.
First m into acceleration will give you force. But here we have force, we have mass and we need to calculate acceleration. तो वो कैसे कैलकुलेट किया है? Acceleration is equal to F1 upon m. So 20 meter per second square हो गया. फर्स्ट केस क्लियर. सेकेंड केस इसमें माइनस क्यों किया? बिकॉज टू फोर्सेस, वन इज ऑन लेफ्ट वन इज ऑन राइट एंड दैट्स व्हाई वी हैव कैंसिल्ड. सर प्लस कब करते? शायद दोनों भी एक ही डायरेक्शन में होते तो मैं प्लस करता. क्लियर है?
Yes.
सर दोनों ऐसे होते तो भी माइनस ही होता, अपोजिट डायरेक्शन माइनस. So third, we are talking about this case F3. Here one force is here and one force is here, right? दिख रहा है ये F3 है and ये F2 है. थोड़े भी एंगल से चेंज हुआ तो भी वो माइनस ही होगा. So here F3 minus F2 ma. So F3 कैसे कैलकुलेट करेंगे? F3 cos theta. So ax फाइनली क्या बना? F3 cos theta minus F2 upon m. So F3 क्या था? 1 न्यूटन and angle 30 degree. So 1 cos 30 minus 2.
Yes.
Fine. Divided by 0.2 kg. So you will get the answer minus 5.7 meter per second square. Show me your textbook. Okay. If we will compare this textbook, so laws of motion, it has kinematics, dynamics, then Aristotle fallacy. So an external force is required to keep a body in uniform motion. What is Aristotle? An external force is required to keep body is in uniform motion. So if we take an example of fan, then fan needs the electrical force to maintain its motion. And then next is Newton's law of motion. So we have completed first law. We are in second now and then we will move into third. With respect to second law, we have seen one numerical Yes, here also one example is given. A hose pipe used for gardening is ejected water horizontally at the rate of 0.5 meter per second. So acceleration is given over here, or velocity is given over here. Area of a bore of a pipe is 10 centimeter square. Calculate the force. So here we need to calculate force horizontally. So that is F is dp by dt, momentum by time. So momentum is nothing but mv, m is mass, v is velocity. So if you will multiply that, you will get the answer for this. Okay. So you can solve 4.1. Next is inertial and non-inertial frames of reference. Inertial frame of reference and non-inertial frame of reference means if we are talking about mass, force, right?
Yes.
And if the object is opposing, that is inertial frame, and where there is no opposition of the object, that is non-inertial. One is inertial and second is non-inertial. Then we have seen the type of forces. It has mentioned 4.5 types of forces, fundamental forces in nature, gravitation and other forces. You can easily go through with this. Strong force, electromagnetic force. Okay, few other free body diagrams and the calculation numericals are given that we'll see. Okay, we'll get back to this once we finish all this. I hope you understood.
Yes, sir.
Now, gravitational force. Gravitational force is a vector expressed by Newton's law of universal gravitation. So that is Mg is equal to G m upon r square. So we are already aware of this. If two objects are separated with the distance, right, r, m1, m2, then there must be a force which is directly proportional to m1, m2 and inversely proportional to r square.
Yes.
Right? And to calculate this mathematically, we need one constant, so we have mentioned this G. This G is UGC, universal gravitational constant. The m, small m belongs to our mass or the mass of object, and capital M belongs to mass of earth. Capital R belongs to radius of earth. Fine. It is mentioned over here. Now in this picture, the direction is pointing downwards. Okay, wait. The magnitude of the gravitational force acting on an object of mass m near the earth's surface is called as weight, and weight is nothing but m into g, and g can also be found from the law of universal gravitation, and weight has a unit of n. So just now we have seen this formula. F is equal to G m upon r square. And if I mention this F as gravitational force, then that is G m upon r square. Now you can ask question, sir, यहाँ पर तो small m था, यहाँ पर आते हो तो कहाँ चला गया? Right? Looking at the weight of or mass of earth, it is very large than any object present on earth, right?
Yes.
So we are neglecting that mass, and that's why we have written only m, because even if we will take that, even if we will consider that mass, the value will not change much. It will change by 0.00 some digits. So that's why we have neglected that, and by putting the value of mass of Earth, radius of Earth, and universal gravitational constant, you will get the answer 9.8 meter per second square. But keep this in mind, on poles our Earth is not complete spherical as shown in this figure. It is having a bulging at the center, and it is slightly bent or slightly decrease in the curve on the north and south pole, right?
Yes.
So here the gravitational pull is 9.83 meter per second, and on here center line we have 9.8 meter per second. Fine.
Yes, sir.
Weight depends upon
Location.
location. So normal force, force from a solid surface which keeps object from falling through, and the direction always perpendicular to the surface. Magnitude depends on situation. I think ये बंद कर दो AC. So normal force, एक ब्लॉक रखा गया है, उस ब्लॉक के ऊपर एक फोर्स नीचे की तरफ है, एंड वर्टिकली अपवर्ड इज नॉर्मल फोर्स. सो फ्री बॉडी डायग्राम जब ड्रॉ करना है तो हमें याद रखना है कि ऑब्जेक्ट कोई भी शेप का हो, हमें ऑब्जेक्ट के शेप से कुछ लेने देना नहीं है. उसका फोर्स कहाँ पर है? डाउनवर्ड्स. 99.99% the force will be downwards. The force will be downwards. Okay?
Yes.
And normal force will be opposite to that, or always upwards. So we have written Fn is force normal, Fg is force towards gravity, and the point represents block. So here magnitude depends on situation. N minus Fg, N minus Fg, दोनों opposite है ना?
Yes, sir.
So just before we have seen opposite रहेगा तो उसको क्या करना है? Subtract. N minus Fg is nothing but M into A, right?
Yes, sir.
So अगर मुझे इसमें Fg में वैल्यू चेंज करना है, मास into gravitational force, so I can put Fg as mg. So from this what will be cancelled? M will be cancelled.
Yes, sir.
Or I can just write, or I can just cancel out this MAY. Why? Because the force which will act will be same as that of mg.
Yes.
Vertically जो भी होगा वो gravity के accordingly होना है. So I can mention n as mg. Okay.
Yes, sir.
Now tension. Two people are stretching the rope from both the ends. So forces are acting towards the center and away from the center. Both forces are acting. A taut rope expert exerts forces on whatever holds its ends, direction always along the cord, that is rope, cable, string, and away from the object. Magnitude depends on situation. So when we will get back to this video, I'll request you to pause it and draw the diagrams and forces along with the explanation. If the force is acting force is acting downward, the tension will act as upward. Fine.
Yes, sir.
Here again it is upward. So that is T1 is equal to T is equal to T2. All tensions will be same because all these are connected with same point. Newton's third law. If object 1 and object 2 interacts, the force exerted by the object 1 and object 2 is equal in magnitude but opposite in direction. Or simply every action has equal and opposite reaction. So if both are giving the force, then that F on A is equal to T and that is equal to F on B. So अगर दोनों को मैं यहाँ कैलकुलेट करूँ तो क्या रहेगा? F on A is nothing but minus F on B, opposite in direction. So और एक एग्जांपल अगर हम यहाँ देखें, two objects are there, the force acting from on one by two, F12 का मीनिंग है force acted on object 1 by 2 and here force acted on 2 by 1, both are opposite in direction. Done?
Yes, sir.
The action and reaction forces are on different objects. Okay. Examples check करो. First एक टेबल रखा हुआ है. So इन सबका फोर्स कैसा है? इक्वल, अपोजिट, राइट?
Yes, sir.
अब सिर्फ टेबल हटा दो, सिर्फ उस एक बॉल को मैं कंसीडर करूँ तो वो फोर्स नीचे, अर्थ ऊपर की तरफ फोर्स दे रहा है, इक्वल एंड अपोजिट फोर्स नहीं है, सो बैलेंस्ड नहीं होगा, कभी भी बैलेंस नहीं होगा. सो बर्ड क्यों कह रहा है आई लव न्यूटन्स थर्ड लॉ? बिकॉज अगर बैलेंस रहना है, ज़मीन पर रहना है तो इक्वल एंड अपोजिट फोर्स चाहिए. सर अगर इक्वल एंड अपोजिट फोर्स नहीं होगा तो क्या होगा? सब फ्लोट करेंगे, है नहीं? नाउ आई एम स्टैंडिंग, यू आर सिटिंग ऑन द बेंच. So all these things only because of equal and opposite force which we are giving towards the earth and are giving upward us. So both are giving force to each other. So to maintain our life's balance even there must be equal and opposite force. So ऐसा नहीं है सारे force एक जैसे रहेंगे तो होगा. Okay, it's time to go for free body diagram. The most important step in solving problem involving Newton's law is to draw the free body diagram. Be sure to include only the forces acting on the object of interest. Include any field force acting on the object and do not assume the normal force equals the weight. Normal force doesn't mean that is equal to weight. So आपको एग्जाम में ऐसा फिजिकल पिक्चर दिया जाएगा, राइट? और उसका आपको क्या ड्रॉ करना है? फ्री बॉडी डायग्राम. सो हमने क्या किया, एक बॉक्स यहाँ ड्रॉ किया, द फोर्स इज अपवर्ड एंड वेट इज डाउनवर्ड, राइट?
यस सर.
हिंट्स, क्या क्या हिंट्स है आपको इसे ड्रॉ करने के लिए? फर्स्ट, रीड द प्रॉब्लम केयरफुली, ड्रॉ द पिक्चर ऑफ सिस्टम, आइडेंटिफाई द ऑब्जेक्ट ऑफ प्राइमरी इंटरेस्ट एंड इंडिकेट फोर्सेस विद एरोस, label each force in the picture in a way that will bring to mind what physical quantity the label stands for. तो उसका physical quantity क्या है वो check करो. Draw free body diagram of the object of interest based on the labeled picture. In additional objects are involved, if additional objects are involved, then draw separate free body diagram from them and choose a convenient coordinate system. क्या choose करना है?
Convenient coordinate system.
Apply Newton's second law. The x and y components of Newton's second law should be taken from the vector equation and written individually. This often results in two equations and two unknowns. So solve for the desired unknown quantity and substitute the numbers. So for example, if we are talking about x, then f net with respect to x is nothing but ma x and f net y is equal to ma y. ये याद रखकर हमें हर एक फोर्स को अप्लाई करना है. ओके?
Yes.
ऑब्जेक्ट्स इन एन इक्विलिब्रियम, अभी ध्यान दो, ऑब्जेक्ट्स व्हिच इज इन इक्विलिब्रियम. इक्विलिब्रियम का मीनिंग क्या है? स्टेबल. इक्विलिब्रियम इज स्टेबल. कोई भी ऑब्जेक्ट स्टेबल तब होगा जब उस पे इक्वल एंड अपोजिट फोर्स होगा, राइट? अदरवाइज इट वोंट बी स्टेबल. Objects that are either at rest or moving with the constant velocity are said to be equilibrium acceleration of object can be modeled as 0. So final acceleration क्या होगा 0. अगर दोनों इक्वल अपोजिट है तो acceleration 0 ही होना है. और जब मोशन खत्म फोर्स आप रिड्यूस कर दो या कम कर दो तो ऑटोमेटिकली एक्सेलरेशन क्या होना है 0. फोर्स चला गया, बॉल हिट किया, फोर्स खत्म होने के बाद उसको रुकना है ना दादा. ध्यान से समझो. मैथमेटिकली द नेट फोर्स एक्टिंग ऑन द ऑब्जेक्ट इज नेट फोर्स है ना. सारे ऑब्जेक्ट्स के ऊपर जो नेट फोर्स है वो कैसे है 0. सर कैसे नेट फोर्स 0 है? Let us take example. I am giving a force towards earth is with my weight 60 kg and earth is also giving the same force to me. Sir ऐसे कैसे आप बोल सकते हो earth भी आपको same force दे रहा है? earth भी आपको ज़्यादा force देता तो अगर earth ने ज़्यादा force देता तो शायद मुझे और ऊपर फेंक देता. और अगर मैंने अर्थ पर ज्यादा फोर्स दिया होता तो वहां पे क्या हो सकता? गड्ढा हो जाएगा कि नहीं? ऐसे हो रहा है क्या? नहीं. इट मींस अर्थ इज आल्सो गिविंग इक्वल फोर्स टू अस. सो अगर मैं उसका सम करूं तो क्या होगा 60 इज इक्वल टू 60. 60 इस तरफ आया, 60 माइनस 60 इज 0. सो व्हाट इट मींस मैथमेटिकली द नेट फोर्स एक्टिंग ऑन ऑब्जेक्ट इज 0. Equivalent to the set of component equation is given by summation of fx is 0 and summation of fy is 0. Horizontal रहे या vertical दोनों कैसे रहेंगे 0. So इस ऑब्जेक्ट की अगर मैं बात करूँ तो टेंशन अपवर्ड है, ऊपर रोप से बांधा हुआ है, फोर्स नीचे. सो summation of fy is 0. Summation of fy is 0. Tension minus fg is 0 and nothing but tension is equal to fg. तो दोनों कैसे इक्वल हैं? अपोजिट. ओके. अब ये जो ऑब्जेक्ट दिख रहा है ना उसमें टेंशन दो अलग अलग जगहों से आ रहा है. सो इसका फ्री बॉडी डायग्राम हमें ड्रॉ करना है. तो कैसे रहेगा? ये बाकी सब चीजें छोड़ देना है, ये इस पे फोकस करना है फ्री बॉडी डायग्राम पे. यहाँ पे सिर्फ क्या आएगा फोर्स. यहाँ पे एक फोर्स है, यहाँ पे एक फोर्स है, राइट? और उसका एंगल. सो ये है उसका फ्री बॉडी डायग्राम अभी मैंने जो ड्रॉ किया था. तो आपको ये फ्री बॉडी डायग्राम एग्जाम में ड्रॉ करना है, सी वाला. ये ओके. दिस रिप्रेजेंट्स आइदर फोर्स और टेंशन, जो भी आपको रिप्रेजेंट है, फोर्स की कोई टेंशन नहीं. सो कैलकुलेशन करेंगे हम लोग. फर्स्ट समेशन ऑफ fx. x के लिए चेक करो क्या क्या फोर्सेस है. ओनली 2 फोर्सेस आर देयर विद रिस्पेक्ट टू x. यही 2 फोर्स है ना. ये तो वर्टिकल है. So this will not come in x. So what we have written t1x plus t2x. ये दोनों थ्रेड इसको पकड़े हुए हैं ना. So t1 cos 37 and t2 cos 53. सर ये माइनस कब लेना है और प्लस कब लेना है? हाँ. If we will consider this as axis, then left of this will be minus. Sign convention rule से अगर जाते तो. Then fy is nothing but t1, t2, t3. तीनों भी y के ऊपर भी एक्ट कर रहे हैं. जैसे x के साथ कनेक्टेड है, यहाँ लेंगे तो y के साथ भी कनेक्टेड है, right?
Yes sir.
So addition of all three. So t1 sin 37, t2 sin 53 minus 100. Why minus? t3 is downward. y axis पर ऊपर का वैल्यू पॉजिटिव रहता है, नीचे का वैल्यू ये समझता है ना. और x में लेफ्ट
में माइनस,
राइट में पॉजिटिव. तो ये वैल्यूज लिखा, आंसर उसको कैलकुलेट किया. देन वी गेट t1 as 60 and t2 as 80. वैल्यूज पुट करके कैलकुलेट करोगे आंसर आएगा. ठीक है. Now accelerating objects. If an object that can be modeled as a particle experiencing an acceleration, there must be non-zero net force acting on it. Draw free body diagram. Apply Newton's second law in component form. तो accelerating object के ऊपर, वो तो object rest पे था ना. अभी जो 2 ऑब्जेक्ट किए वो कैसे थे? रेस्ट. नाउ वी आर टॉकिंग अबाउट एक्सेलरेटिंग ऑब्जेक्ट्स। तो ये एक्सेलरेटिंग ऑब्जेक्ट है, मतलब लिफ्ट पे कोई बंदा खड़ा है, लिफ्ट अप एंड डाउन हो रहा है,
Yes, sir.
तो उसमें क्या होगा, दैट इज इंपॉर्टेंट। अ मैन बेस हिमसेल्फ विद द स्केल ऑफ एलिवेटर, एलिवेटर मतलब लिफ्ट, व्हाइल द एलिवेटर इज एट रेस्ट ही मेजर्स ऑफ 800 न्यूटन। जब वो रेस्ट पर रहता है तब उसका वेट जो मेजर किया जा रहा है दैट इज 800 न्यूटन। What weight does the scale read if the elevator accelerates? अगर वो जा रही है upward या downward तो क्या वेट होगा? At 2 मीटर पर सेकंड स्क्वायर, ये स्पीड से अगर वो जा रहा है, एक्सेलरेट हो रहा है, तो उसका वेट क्या होगा? एंड सेकंड क्वेश्चन इज what weight does the scale read if the elevator accelerates downwards to the same 2 मीटर पर सेकंड स्क्वायर? तो डाउनवर्ड के लिए क्या लिया हमने? माइनस। अपवर्ड के लिए क्या लिया हमने? प्लस। So first we will go for upward. Upward is n minus mg.
Yes.
उसको एक नॉर्मल फोर्स रहेगा, ये देखो, बरोबर, mg एंड n। यहाँ तक क्लियर है? So n minus mg is nothing but m into acceleration. So n mg ma, तीनों को ऐड करो, कॉमन क्या है? m g plus a। तो m मुझे पता है 80 है, राइट? एक्चुअली अभी यहाँ पर 800 लिखा है, मैंने यहाँ पर 80 लिखा है। सो ये 800 न्यूटन और यहाँ पर मैंने मास के लिए 80। कैसे?
ये चेंज कर,
क्या चेंज किया है? सीजीएस यूनिट नहीं। अगर एक्सेलरेशन की बात करें तो एक्सेलरेशन कैसे लिखा जाता है? एक्सेलरेशन इज नथिंग बट फोर्स इज मास इनटू एक्सेलरेशन, है ना? फोर्स क्या है? जी, ग्रेविटेशनल फोर्स। सो अगर ग्रेविटेशनल फोर्स है और मुझे क्या दिया है? 800। लेट अस टेक एग्जांपल, ये 800 दिया है, मास और एक्सेलरेशन। एक्सेलरेशन क्या है? ग्रेविटेशनल फोर्स। सो वो कितना है? 9.8 मीटर पर सेकेंड। अप्रोक्सीमेटली मैं उसको कितना पकड़ूंगा? 10। कितना पकड़ूंगा? 10। सो वो 10 इधर जाकर डिवाइड हुआ तो मास कितना आएगा? 80 kg। क्लियर है ना? कंफ्यूजन ऐसा नहीं होना चाहिए सर इधर 80 है इधर 800 है, तो गलती से टाइपिंग मिस्टेक तो नहीं है, नहीं, वो करेक्ट है। क्या किया हमने? वापस ध्यान दो, फोर्स मास इनटू एक्सेलरेशन। फोर्स वाज 800 न्यूटन, मास पता नहीं है, राइट? और एक्सेलरेशन 9.8, उसको अप्रोक्सीमेटली क्या लेना है? 10। सो 800 divided by 10 is your mass, that is 80 kg। क्लियर है?
Yes, sir.
ओके। सो 80 2.0 दिया है, बरोबर?
Yes, sir.
एंड 9.8 ग्रेविटेशनल कांस्टेंट है, सॉरी ग्रेविटेशनल फोर्स है। सो सबको कैलकुलेट करो, यू विल गेट 624 न्यूटन अपवर्ड एंड डाउनवर्ड आल्सो
624.
सेम। ठीक है? क्लियर है?
Yes.
So here ends all the numericals based on laws of motion. So अभी आपको करना क्या है? आपका टेक्स्ट बुक को रेफर करो, उसमें अलग अलग एग्जांपल्स दिए फ्री बॉडी डायग्राम के, एक्सेलरेशन, वेलोसिटी, राइट?
Yes, sir.
Try to solve that examples which are given inside the text lesson and at the end of the lesson. And once you solve all the numericals, you will get ample of doubts, so you can raise the doubts, and second session we will conduct for doubts. Okay, thank you.